Okay, we will talk about compound inequalities today. There are two types of compound inequalities. We have an and we have an or. For and, both inequalities must be true. So here, if we have an inequality that looks like 2 is less than x or less than equal to 5, on our graph, 2, 5, open circle and closed circle, we are looking for the overlap here. And the overlap will be in the middle, right there. So we are looking for the overlap. For or inequalities, one or the other is true. So for example, x is less than 2 or x is greater than or equal to 5. On our number line, 2, 5, open circle, closed circle, x is less than 2, just below 2, and x is greater than or equal to 5. So here the solution is either x is less than 2 or x is greater than 5. It could be anywhere on that number line where it is shaded, not just the overlap. So solution is all shaded part not just the overlap. Okay, so for this first example, first we have 3x plus 5 is less than or equal to 11, or 11 minus 2x is less than 5. So first, let's go ahead and solve for x on these. So on this first one, 3x plus 5 is less than or equal to 11. Let's go ahead and solve. So then we get 3x is less than or equal to 6. Divide by 3, x is less than or equal to 2. Or we have 11 minus 2x is less than 5. So subtract 11. Negative 2x is less than negative 6. X is greater than 3. So if you are dividing or multiplying by negative, you need to flip the sign. I've had questions on that. It is only if you are dividing or multiplying by a negative. If you are dividing or multiplying by a positive, you are fine. If you are dividing or multiplying by a negative, you have to flip the sign there. So then if we put this on a number line, we have 2 and 3. X is less than or equal to 2, so I'm going to close my circle. And it's below that. Or x is greater than 3, it's an open circle and it's above 3. And then in my interval notation, anything below 2, so negative infinity to 2, and I'm going to use a bracket because I can include 2, union with 3 to infinity. Notice how I used a parenthesis for 3, since 3 is not included, and then we go up to infinity. Okay, on this one, I want you to try, and then I will have the answer up here, so go ahead and pause the video. I want you to try 4 minus x is less than negative 3, or 3x is less than or equal to 15 minus 2x. Go ahead and try it. Pause the video here. Okay, so hopefully you paused the video. And the answer that I got for this problem, x is greater than 7, or x is less than or equal to 3. And when we put this on a number line, remember that we always go in numerical value, so 3 comes first, and then 7. X is less than or equal to 3, or x is greater than 7. And then the interval notation, negative infinity to 3, 7 to infinity. If you did not get that right, hopefully you see where you made your mistake. If not, come into class and ask me what happened. Okay, for example 2, this is an and inequality. So we are looking for the overlap here. You can go ahead and do it 2 ways. You can either split into 2 inequalities, or you can go ahead and solve as one. So you can split or solve as 1. So if you split into 2, that would be negative 1 is less than 2x plus 7, or we have 2x plus 7 is less than or equal to 19. So solving this, subtract 7, negative 8 is less than 2x, or x is less than negative 4. And then minus 7, 2x is less than or equal to 12, where x is less than or equal to 6. And that's what you would get. Or if you go ahead and solve as 1, negative 1 is less than 2x plus 7, which is less than or equal to 19. You would just have to do it on both sides. So if I subtract 7 here, subtract 7 on both sides of your inequality. So I'd get negative 8 is less than 2x, which is less than or equal to 12. Divide by 2 here, so I'm dividing by 2 on each side. So I'd get negative 4 is less than x, which is less than or equal to 6. And then if we go ahead and put this on a number line, we have negative 4 and 6, open circle, closed circle, and again we are looking for the overlap. So I'm going to go ahead and use my colors here just to show you. So negative 4 is less than x, or you could say x is greater than negative 4, which is right here, or x is less than or equal to negative 6, or to 6, so you would shade below it, and then our overlap is our answer. So our answer is only this part in the middle because that's where it overlaps. And then our interval notation would be negative 4 to 6. There. All right, you go ahead and try 7 is greater than or equal to 3 minus x, which is greater than negative 3. Again, you can split it up into solve, or you can solve it as 1. Okay, so I solved it as 1, and I got negative 4 is less than or equal to x, which is less than or to 6. And then if we put this on our number line, negative 4, 6, shade in, this would be an open circle. Or if you split this up, it would have been negative 4 is less than or equal to x, and then x is less than 6. And then again, if I use my colors, so yellow, negative 4 is less than or equal to x, or x is greater than or equal to negative 4, which is right here. And then x is less than 6, x is less than 6. And again, we are only looking for the overlap for this one because it is an and or a compound inequality, so we are only looking for that inner overlap. So that middle part is the only part that would satisfy this equation. And then to write our interval notation for it, we are starting at negative 4, and that is a closed circle, so we are going to use a bracket, negative 4, and we are going to 6, and we're going to end with a parenthesis there.